Hey everyone, welcome to the fourth installment of DevOps, the what and why of DevOps. Today, instead of having a lab activity, I'm going to try to do a bit of an extended review of all the concepts we had. I'm going to start that review with crowdsourcing, which means I will be asking you all to simply in chat recall some of the and then also go through kind of a guided question and answer review as well, so that we can cover some of the things that we've been chatting about. Let's hop into today's one second here. Hop into today's content. And all right, so today we'll be talking about the what and why of DevOps, of cloud and automation. So cloud and automation, you don't have to be using cloud necessarily to do DevOps, but the cloud is kind of a somewhat natural outcome of applying these principles in earnest. And so we'll kind of learn a little bit about how the cloud plays into the whole concept of DevOps and maturing the application development model. And also automation is critical, and we'll learn about why automation is critical today as well. How many of you have heard of minimum viable product? Go ahead and use your thumbs up emoji if you, or raise your hand, whatever works for you. Okay. Anyone can tell me sort of a definition or what your impression of it is? There's not really a wrong answer here, because I don't think it's necessarily a well understood principle unless you read the source book from which this terminology came from. But does anyone want to brave giving us an overview of what a minimum viable product is about?
Yeah, I can try. Basically, like, our product can be really big and broad, can be a lot of features, but also, like, when we think our product basically has some core functionality, so we can start to use it. And minimum viable products basically describe that's like what is that core functionality we can start with working on, and then we can add the other features on the way. I don't know, this is my definition.
Yeah, that's a good summary. So minimum meaning as little as necessary, viable meaning it works well enough to be used, and product meaning focusing on basically the problem solution fit. This concept it really came into zenith with the book called The Lean Startup by Eric Ries. He also has another book that I'll mention that is called The Startup Way. And the Startup Way might actually be a lot more applicable to many of your jobs at companies. If you're working for an established company, you're not in a startup, then the Startup Way adds some really important qualifiers to these concepts that make you apply the concepts of Agile more successfully in an established organization. But minimum viable product, kind of points to the concept of minimal viability or minimally viable. And minimally viable automatically implies something that this is a specific state of an application. Can anyone think of other states that are similar to minimum viable that this application might be in, so that it's not just minimally viable? Can you describe a state it might be in? So one state is if it's not minimally viable, then it's non-viable. So it doesn't work at all, or what Agile would call a failure. And so we know there's at least two states, but also when someone is saying something in a meeting where you're trying to create an MVP and they say, hey, you know what? I don't know if this particular choice we're making here is going to really work in a scaled production environment. And they're generally told, we don't really want to talk about that because you are early optimizing. And so optimizing or optimal viability is another possible place on that benchmark. So one thing to keep in mind is that MVP indicates viability, and it's a fit to purpose scale, which means how well does a particular thing fit the purpose for which you intend it. If you think about Olympic athletes, how many of you would say that the gold medal winner in bench press weightlifting is fit? How many of you just do your thumbs up or your hands to say you think the gold medal winner is fit? Okay. What about the individual who wins the gold medal in figure skating? If you've watched figure skating, it's really accurate. How many of you would say that the person who wins gold in figure skating is fit? All right. Same folks saying, yep, that person's fit. How many of you would say that the person who won the gold medal in bench pressing is fit to win the gold medal in figure skating? No takers. So fitness is always fit to purpose. We kind of overlook it, but it's how well does something fit for the purpose for which it was intended or for the purpose for which it's been designed. And so fit to purpose means fitness is not, you can't just say, you can say an individual is generally fit, meaning that they're fitter for just general life, but it's still the purpose of general life. So we kind of think of CrossFit sports where people strengthen lots of muscles. They strengthen muscles tone wise. They don't necessarily bulk up. They're probably fit to purpose for general life and general sport. But it's still, there's a purpose in mind when you assess fitness. So this viability scale might look like this. So you can see here we have on the left, non-viable. Minimally viable simply means just enough to be working so that we can play with it and test it. Sufficiently viable is another standpoint at which it's sufficient to some purpose. Another concept you might have heard of is minimum marketable product, which means basically, will someone pay money for this? So we generally have to get a product or a feature. Very many times we're actually doing this at the feature level instead of the entire product level, to sufficient viability, sufficient that someone will pay for it or care enough to try to use it if it's a free inclusion in your platform. Optimally viable is where it solves the problem really well or maybe even uniquely. And ultimately viable is where something does the best possible job we can imagine of anything that might address that. So viability is a fit to purpose scale, and it applies to two of a customer's concerns. So the concept of product, or basically product solution, problem solution fit, focuses on, do the features in the product, let's put this on the screen, does it solve a real customer problem via customer acceptable experience? So have you solved something they care to solve? Sometimes we experiment with things and customers are like, yeah, it's a problem, but it's not worth having a whole product to solve it or a feature. It takes 3 seconds of thinking and everyone does it naturally. So thank you for trying to solve that problem, but it's not really a problem. Another possible outcome is, yeah, you've solved the problem, but there's 44 steps to a problem that a human does naturally in what seems to be like 3 steps. So it's not really an acceptable way to solve the problem. So MVP really focuses on product feature viability or product feature fit to solve a problem. But the other one that we try to bring in with DevOps is operational viability. And this is assessing from the customer's perspective, is it available to solve the problem whenever they need it? And it's my contention, and I haven't found this anywhere else on the interwebs yet. So if you find it, I would love a reference, but it's my contention that the same customer has different expectations of both of these. So the customer has an expectation that if you're playing around with a new feature, especially if it solves a problem they didn't even know they had, or that it solves something unique that really gets their attention, they're kind of willing to see a minimal viable one and play with it and give you some feedback. But that same person, when you say, hey, we've now made it available so all of your employees can use it, is not really interested in minimal operational viability. So if you say, hey, sometimes it'll work, sometimes it'll be broken, sometimes it'll corrupt your data. That's all minimum viable is about, barely working. They're not really going to be interested of that same feature. They might be okay with some operational problems for qualifying the product feature fit. Does it solve a problem? And oops, hey, it broke this time. We know you guys are still working on it. But when it comes to operationalization, when you put in operations, they're not very interested. The Lean Startup also talks about the purpose of MVPs. MVPs. It's expensive compared to the older way of doing things, of trying to figure out what we need up front. What is the outcome of an MVP iteration? So it's for learning. So it's a very expensive but very effective way to learn. So we build iterations and we keep getting qualification from the customer if we can keep them engaged. Oops, I got some chats coming in that yeah, you've never seen this chart because it is an original that I've put together. That's why. And this comes from, I came from an ITIL background, so a very—
Oh, I love it. I want people to see it all the time. It just explained, so it was such a great explanation of it. So yeah, I want to see more of this chart. So
okay, well, I might blog it then. I encourage you. So I came from an ITIL background, and then I stepped very much into agile environments, and I see agilists trying to escape the slow ITIL change management where everything's about stability because they want to innovate. But then at the same time, they struggle with operationalization because they maybe don't get that the same customer who wants to experiment with new features doesn't want them to be experimental when they go to use them in a more production nature. So whenever a new to the world product out, the customer's expectations are generally that if you engage them as what's called an early adopter, that you'll proceed from a minimally viable kind of solution and through feedback get to sufficient viability. And then if that becomes a permanent part of your product, get to optimal viability. So they accept that first stage there, especially if they get to give you early feedback. However, when it comes to operational viability, that same customer, when you say, hey, it's good for all 1,000 of your employees to use this now, they're not interested in finding out that it hardly ever works right, or it works wrong even 20% of the time, or it corrupts data at all. They're just really not interested in that. So just keep that in mind, that I think everyone has this kind of four square in their head, or this viability scale, but it's against two concerns, not just one concern. I'm going to throw in one more little monkey wrench, and that is the book, The Startup Way, talks about how you should not use what he calls innovation accounting for well-known problems. So what this means is, if you're building the next accounting software package, learning how to do accounting through MVPs because your developers don't have any background in accounting is not going to be effective. Accounting problems have, on the whole, been well solved hundreds of times, and there's many companies making billions of dollars with accounting software. So because of that, they need to be managed with more of a stable systems perspective. And so I'm going to even be bold and say that on well-solved features, customers' expectations start from sufficiently viable. And the way you might be able to sense this, if this happens to you, is you're having a hard time getting early adopters to look at your version of the accounting software. Because the analogy I give is, you come into my bicycle shop, and you say, hey, Darwin, I need a rear wheel for my bicycle. And I hand you a stone disc, and I say, go ahead and mount this on your bicycle. We're still trying to figure out exactly the best way to build bicycle wheels. So we'd really appreciate your feedback. Of course, if you were the customer, you give them a blank stare and simply walk out because you don't want to say bad things about them. But you basically have this expectation, well, bicycle wheels have been well solved for over 100 years. I really think that it behooves you as a person who wants to make bicycle wheels to go check out this well-solved problem and start with sufficiently viable. Really ought to have a rubber tire and be made out of metal and probably have spokes. So I think if you look at that, sometimes if we over-index or over-tilt towards agile concepts, we can start justifying odd things like building things that have been built 1,000 times. We build them from scratch, and we don't interact with any external expertise on the matter. We just try to learn, let's make a biochemistry application with, no input from biochemists. We'll just start and learn forward. It's not going to work. So just keep that in mind as well. Agile is awesome. I've loved how it's influenced my work. But when you over-index to anything, if it's the next new thing that displaces all previous things, that's also cause to be suspicious that it's being over-applied or over what Gartner calls it's in the hype cycle. So it's like hyped up to be the silver bullet that solves all previous problems. That's really marketing. It's not really practicality. So any questions or thoughts about viability and where MVP might fit and where product feature fit versus operational viability? Have you had experiences that either back up or challenge this perspective? Anyone's free to call out or text out. Okay. So let's talk a little bit about why is automation necessary. I always like to find out, before I tell you kind of the world according to the trade press or the world according to Darwin, I like to also find out what thoughts spring to your mind when a question like this is posed. So does anyone want to either chat or voice some thoughts about why you think automation might be necessary for DevOps? I probably should have said for DevOps in this sentence. Okay, no problem. We'll keep going here. The first issue is scale. Too many computers for individual attention. Now, I started my career in desktop computing, and very early when desktop computing was just starting out. And I worked at a college at the time where when I got to the college, there was one personal computer in the library. By the time I graduated and started working there, there was 300 personal computers. And already at that point, it was impossible for us to give each one individual attention. That was a span of about 4 years at the beginning of desktop computing. So right at the beginning, almost as soon as desktop computing emerged, so did the need for automation for desktop computing, because there was just too many to give individual attention. That effect was not being felt at the server at this time. At this time, you'd have a very high ratio of administrators to servers. So if you had 5 servers, you might have 2 administrators, so 2 to 5. But if you had 300 computers, you might have a 1 or 2 to 300 ratio. And so that ratio, it's really just an economic thing. You can't hire 3 full-time technical employees for every workstation in an organization. And so scale. So then when we fast forward into DevOps in the era of the cloud, all of a sudden servers are scaling in the same way. And we need to start to automate because there's no way to hire that many people, 1 person for every 3 or 5 or even 15 or 20 machines. So scale is one reason why automation is necessary. We can't scale human labor to keep up with the manual activities. Speed, go ahead.
Well, I guess to that point, right, I actually chatted a response. I thought that we were going to go the chat route, but I said that in the long run, it saves you time. And I guess I should have put manpower, but that like rolls right up into what you just discussed, that you can allot to other tasks. And yeah, so I just wanted to chime in with the response before
Definitely. Great response, Peter. One thing that I have found that's challenging is for some reason, even folks who are been developing applications for years consider automation kind of once and done, but it's also code as well. And it also requires maintenance. And I don't know why it so frequently gets overlooked. So I don't believe in some people call it the concept, if you have to do it twice, automate it. I don't agree, because sometimes you dig in some really deep rabbit holes to automate something. So I actually believe that one ought to look at, if a human does it for a year, how many human hours does it take? And how many human hours will it take to not only build the automation, but maintain it? And sometimes people are going over that ratio in a bad way. So they're saying automate, automate, automate everything. Well, again, another one of those like slam to one side of the spectrum ideological positions. And they actually end up spending a lot more time and money automating something that only takes one person 4 hours every 3 months. So 16 hours a year. And they spend as someone who knows how to automate, that's usually a more intensive skill set. So it costs more to get them to automate it and costs more to get them to maintain it. Or automation that has to be updated every time it's used because it's used so infrequently is another example of an anti-pattern. But absolutely, if you look across your whole labor force, if it's something that's highly repetitive, then it does save you time, absolutely. Speed. So agile is not, agility does not mean just speed, if you haven't thought about it before. I have a slide I should have brought in here with a picture of a Bugatti Veyron, goes like 250 miles an hour, and it eats 7 gallons of gas per mile or something like that at that speed. Then I had a picture of an off-road four-wheeler. Oh, and in the case of the Bugatti Veyron, the road has to be perfect, because if it hits one rock, the thing's probably rolling down the road in a big mess. Then the next one was an off-road vehicle with four-wheel drive off-road vehicle, and it basically gets much better gas mileage, and roads are optional. And then the third one was a picture of a football player dodging someone. And so agility is also about making changes, not just moving at speed. So it's a balance between being able to change direction as well as speed. And so the football player can actually, if humans could drink gas, they could do something crazy like 20,000 miles on like 1 gallon of gas if we were able to metabolize gas. And so that gives you an example that speed is not the only part here to agility, but it is a big part of it. And so as we speed up all these processes, if we have an army of humans performing them, then we can only go so fast because there's just too much lag time between humans communicating. And then safety. So one of the things that made why DevOps came on the scene was Agile started affecting development. And developers could now crank out releases like multiple times a day instead of every 3 months. And operations was not keeping up, because operations was like, we can't apply these changes as quick and it's destabilizing production. So unless you take into account production concerns right in the building the software, we refuse to push it this fast. And so consequently, there's a ton of testing in CI, as we talked about on the second day, tons and tons of testing, and that's about safety. Well, if all that testing was done by humans, once again, we couldn't have the speed in automation. So these are that require automation. There's probably other areas that you could think of as well. Just in the terms of the scale of our compute nodes, so what goes on with compute? It used to be one mainframe, so you could hire 1 to 5 to 15 individuals to take care of it. It was doing all the compute in your organization. Now we go to thousands of containers. There's not really going to be a way to say, hey, we need an admin for every 5 containers. So we really need automation in multiple forms in order to accomplish scaling horizontally. That's another concept too that you should keep in mind, is that horizontal scaling is what is done when we do containers. And what it means is we just add more nodes, where vertical scaling was the rule with mainframes and even general computing devices, that we grow the size of the individual computers as opposed to growing the number of individual computers to handle the scale of the load. And then safety. So keeping testing costs in line. If we plot speed multiplied by thoroughness, so this bottom axis is if you said, hey, I want to do a release every 2 weeks. And by the way, we not only have unit tests and functional tests, we now want to do performance tests, security tests, and you just keep adding more tests. You can think of those two as being a multiplier. So the more thorough you make your testing, and then you multiply it by how many times you want to deploy, well, you get this line would grow very fast to the right. How much is required to be both fast and thorough? The more fast and the more thorough, you increase either of those, and you're going to dramatically increase what you need on this bottom scale. And then the other one is the cost of testing. So how much is it going to cost to be fast and thorough? If we look at what it would cost for manual or human done testing, it would probably follow a curve like this. And at some point it would go straight up, which means you simply can't do it anymore. No matter how many more humans you add or more processes or anything, you top out, you literally can't go any farther. Where if we look how automated testing follows, it does increase, but it can be more linear. It may not be completely linear like I've depicted it here. It might still have some curve to it, but it's gonna be much less. And basically this follows the agile concept of agile team size. Does anyone know what Scrum says your agile team size should be between? What and Google has a famous statement about teams. It has to do with pizzas. Does anyone know what that statement is?
I think 6 to 8, if I'm not wrong.
You're very, very, very close. So it's, I think they say for the Agile certificate or the Scrum certification test, it's 7 plus or minus 2. So
Okay.
down to 5, so very, very, very good answer. The reason for this that they give is that as you increase the number of people in a group, at some point, almost every person has to communicate to every other person. So it becomes an exponential scale of syncing up with others if you're really going to be in tight communication and really one team. So if you have every person you add, it starts to get exponentially how many connections there are in a group of nodes that are all connected to each other. It's just a kind of a mathematical thing. And so that's why manual testing follows this as well. Manual testing is also complicated, not just by human handoffs, but in, all kinds of manual instructions, which are almost as intensive to maintain as code itself. All right, so any thoughts, questions, or reflections on safety, keeping testing costs in line? All right. So let's talk a little bit about the types of automation that exist. The green and blue blocks are supposed to be animated. They're not supposed to be there yet. So just pretend they don't exist. So we'll talk a little bit about the front end and back end, also known as full stack if you're a developer who attempts to do it all. And this isn't technically automation. This is the core part of creating the value of the actual application. But I wanted to depict it because it's obviously the main thrust of what the software engineer does. And so the software engineer develops that, but frequently the types of automation that they're tasked with is build automation. So maybe you have an IDE and you just push a build button and it does a lot of things for you. But as soon as you make this into CI, you generally have to write some code to tell it, take the code, now do this to it, now do that to it. And they're typically steps you might also run if you do your builds in a command line and interface in a prompt. Well, they'd be the same steps that you do inside of that command prompt would end up being in CI. Another type of automation developers end up doing is test automation. Has anyone heard of SDET, S-D-E-T, as a role? Like you can go out and get on Indeed and look for SDET roles. This is a special type of software development. It's software development engineer in test. There's an entire sub role of developers that do nothing but build test automation because it's very intensive and there's very many kinds of it, lots of tools and lots of languages that can be used for it. We then have container templates. So building a container template or building a container basically that can be used to do something useful. And this is a form of a runtime environment. Frequently, software developers are responsible for making the containers that their software will run in if indeed they are containerizing it. We also have OS virtual machine templates. So if your software runs on instances, not on containers, then a lot of times that is at the same layer. But a lot of times that's the point at which a solution engineer or ops will actually work on creating those templates. Solution engineers also create container templates, especially for build systems. And software development engineers can also create VM templates, or they at least specify all the commands to install the prerequisites for their software to run in that VM, which ends up being the information you need to make it into a VM template. We then have release deployment. So when we deploy a release into production, we need to have a certain approach to that. So that can be containerizing. It could also be creating packages out of your software. And so sometimes this is the task of software engineers, and frequently it's the task of solution engineers. Then we have runtime environment provisioning. So you've specified either a VM template or a container template, or maybe you're fully native into Amazon. And so you've specified the way to build, say, a serverless container. So we need to deploy that runtime environment. And usually that falls to solutions engineers to get that runtime environment set up so it's running in the infrastructure. Infrastructure provisioning is different. So this is where we deploy potentially massive pieces of infrastructure or front ends, load balancers, things that allow the traffic to come into the environment and then be utilized across the compute infrastructure. Monitoring ops. So this is ops automation monitoring, so that this is not technically either build or provisioning. Now we're automatically monitoring the software while it's running. So this is really ops automation. That usually falls on the ops side. And then self-healing ops automation. Now, sometimes when we talk about agile, they use the concept of a startup where there are no ops roles. And while this is good in theory, it's very hard for an individual human being to know all of this. Agile also has the concept that a Scrum team should be capable of delivering all functionality required in order for you to deploy an application. And so because of that, agile teams need to have that competency. It's actually a question on the Scrum certification exam that tries to confuse you, that basically says all team members should be competent to do all tasks in the sprint to get the sprint done. And the other option is the team should be capable or competent to do all tasks to get the sprint done. And if you pick each individual should be competent to get it all done, then that's wrong, because it's impossible. And so that's why you have a team, is people have different specialized roles. It's also important to understand that a lot of times in big organizations or super scaled stuff, each of these layers might have specialists, people who specialize completely in doing that one part. I've been on teams that deal with developer productivity, and we would build tools all throughout the stack so developers could think less about the green boxes. Amazon and other clouds also have toolkits that allow developers to think less about the green boxes. On Amazon, they have a service called Amplify, which lets developers with very little knowledge of infrastructure's code deploy massive infrastructures into Amazon by just running a few commands. And okay, now I got a scaling database that won't ever go down. I ran 2 commands on the command line, and now that's what's going to happen when I deploy it. Some things to be aware of is that test and infrastructure automation have many domain-specific languages, or DSLs. So you're familiar with the programming language you use, and you're familiar with there being a lot of other programming languages. Well, when you get into test automation and infrastructure automation, there's a whole bunch of other languages, and even CI has its own languages. There's GitLab CI YAML, which is its own domain-specific language. So there's lots and lots and lots of languages. I did want to point out, however, though, if as a developer, you're wondering, yeesh, where should I dabble in this? The fundamental shell languages are highly recurrent. So even though these other domain-specific languages are around, the Linux shell or Bash, there's both SH and Bash, and PowerShell, which is now multi-platform and open source, recur frequently. So I'll give you, for instance, GitLab CI YAML is a certain language, but when you get down to the individual stages, you're running one of those 2 shell languages. So if you're running on Windows, you're probably running some PowerShell command job. And if you're running on Linux, you're probably running some Bash commands inside of that job. You can use other shells. So if you install Python, you can use Python instead. But just be aware that these 2 shell languages occur again and again. If you're on Windows, PowerShell is extremely easy to step up to and get into. Linux shell, on the other hand, is actually the opposite. It's quite challenging to learn it because there's no consistency between commands. All the commands have been developed individually, where in PowerShell they've been developed according to a consistent schema, which makes learning it very quick, and it's got lots of built-in metadata and help data. If you're in a Linux shop, though, you probably don't want to be the only person doing PowerShell on Linux, because it's just creates political friction or opinionated friction. Also, if you ever have to automate end user deployments to end user desktop devices, so Mac laptops, Windows laptops, no one really uses Linux on the desktop, but if you did, it's way harder to server automation. So just keep that in mind, because the user is using the machine, they're locking things, they're constantly configuration drifting it. So just keep that in mind, that if someone says, do you want to write the installer for this, for the desktop version of the software? You're stepping into a very big and difficult domain that can be pretty challenging to work through. I started in desktop, and when I transitioned into DevOps, where I did almost all server automation, it was legions simpler and easier to get deployments to succeed. All right, we've seen this chart before. All right, let's just go back one. Anyone have any thoughts or observations on the previous slide? I'm gonna have to speed up a little bit here.
It's shown, and is there a kind of relationship between software engineer, dev, and solutions?
Yes,
the graph is drawn.
Yeah, we'll be taking.
Yeah, go ahead.
We'll take a look at that in a further slide, because I'll encourage that you all have obviously jumped into software engineer, but I feel that we actually have personal neurological preferences that a lot of software developers, or even people who are in regular engineering, like chemical engineering, will find that they really enjoy the solution engineer role, because it's just a different way of processing how to solve problems. And so we'll talk about that. And there are some people who can potentially range between both of these very comfortably, but that's kind of like a Michelangelo or a Renaissance person. It's not a frequently occurring thing. The concerns that you have to deal with are so different that you have to become proficient in those concerns. And that's another thing too, is that even though everything in the green boxes is software, it doesn't mean that the person who develops, say, a regular end user application understands all the different concerns, limitations, the practical daily wisdom of how things have to be done to get it out and running. And that's been actually a perception problem that DevOps tries to heal. Okay, so 12-factor app, automation as first principle. What I'm going to do is I'm going to push a key, and it's going to animate this, and we're going to drop away the ones that do not necessarily directly support automation, and we're going to add in a little gear icon to the ones that do. So once again, if you follow the principles of the 12-factor app, it's going to take care of a lot of the automation priorities. So here we see 9 out of the 12 directly or indirectly support automation. I should also point out that although last time we showed you Docker on here and how it supports this, you don't have to be developing in Docker to follow these principles. And to the degree that you follow them, they will help you even with traditional non-containerized apps. I think I mentioned before, I had one organization where I worked where they put individual customer IDs into the code to cause configuration changes. And it was nearly impossible to DevOps automate that, even though it had nothing to do with containers. And if they had followed number 3 here and number 1, store all config in the environment, not in the code, and code base, one code base, many deploys, then, and of course it was a legacy app. These principles weren't around when the app first was built. So it wasn't the fault of the engineers. It's just that you want to get to this as quick as you can if you're dealing with legacy code. Okay, so you asked a question contrasting the builder dispositions of software engineering and solution engineering. So you probably heard of life hacks. You see these videos where someone takes, I don't know, they take something intended for one purpose and use it for a completely different purpose. You probably know of Legos or even played with them as a kid, or have young people in your life that play with them. Maybe you've seen the Junkyard Wars reality TV show. There's also Robot Wars. College students create robots to war against each other. But all of these reflect the concept of making something fit to purpose by maximizing available parts that are already built. with a lot of glue and tape technology. So if you were physically making something, some of these life hacks, you physically take, I don't know, an old plastic bottle and some duct tape, and you do something with it that's really useful around the house. And in technology, we have specific domain-specific languages that kind of act like glue and tape to put together other things. Infrastructure as code is sort of a gluing language, a gluing capability. So this is the most like solution engineering, making things out of found parts. Now, these aren't really hardened categories. You know that as a software developer, if you're using open source componentry, you're basically reusing made componentry. But this is usually at the next level up, where you're fitting working applications together with other pieces to make a solution. And then we have, human pursuits like pottery, carpentry, painting, metalworking. Take very raw materials and you make it fit to purpose by custom building something. You build a nice piece of pottery or a functional piece of pottery. You build a home or a cabinet. You paint a beautiful painting that's could be based on a landscape, or it could be something that is more just impressionistic. Metalworking, all of these, you're taking raw materials and building something fundamental that hasn't existed before, so to speak. In solution engineering, you can still build assemblies, very complicated assemblies that haven't existed before. And that's part of the thing that I really enjoy about solution engineering. But pottery, this concept, which is more like software engineering, is more fundamental, dealing with something from the ground up. We then also have, what I really feel about this is that there's some sort of fundamental creative expression that causes people to be more happy in one of these than the other. I've just seen it all through my career when I help people do career planning, that they might find that they much more enjoy one of these than the other. So if you haven't been able to experiment in both realms, just pay attention as you're doing your job. Maybe do I call it designing your life experiment with the other domain if you have an opportunity. So if someone's like, hey, we need someone to automate X, Y, Z, and you're like, oh my goodness, that's a lot of learning. Maybe step into it. You might find that you enjoy it. By the way, I don't know if I mentioned the book Designing Your Life, but and there's also Designing Your Work Life. They're great books about using iteration and building forward in order to figure out what to do in life. And so that you actually apply the principles of agile and design thinking to your actual concept of exactly what you want to do in life. And it's not just the work realm, but all realms of life. Any questions or thoughts or observations on that? Right. So what is the cloud? I feel this is my broadest statement of what the cloud is. It's the natural outcome of the economics of owning and operating equipment. So when you own and operate any equipment on the planet, usually for your own personal benefit or for business benefit, there starts to be an economic effect of it. And it's applied to computing in much the same way as it happened in transportation or power. Electrical power would be another great example. And this concept is known as commoditization. So if you wanted to have electric power at your plant right after it was invented, you would probably have to build a generation plant. Maybe it's hooked up to water or wind, and then wire it. You'd have to know how to maintain it. You'd have to do it all yourself. But now electrical power is so commoditized that even the clouds, they'll have backup generators, but they don't try to generate their own primary power because it's commoditized, which means you just go somewhere and turn on a faucet, just like running water in North America is commoditized. Turn on a faucet, boom, there's running water. And so this is what has happened to computing, and the natural result is the cloud. So you might think the cloud is the result of innovations, and it is, but it's the economic pressure that creates the innovation. Let's actually go through an example of this using transportation. So we're going to go through several phases of how you might acquire some transportation. Let's say you're in one city and someone you want to visit is in another city. We're going to talk about the ways you might get there. We're going to look at the factors of who made the vehicle, who's responsible to get the right size vehicle and to resize it if this week you're going over just for a social visit and next week you're hauling several pieces of large furniture, and you have to have a different capacity of transportation to do that. The maintenance costs and then the usage costs. The maintenance cost is like tires, and usage cost is like gas, and then whether or not there's any sharing of the costs. Also, who operates it and monitors it. So when you drive a car, you should know what your engine light and your oil light indicate and what the temperature gauge does. So who operates and monitors it, and who pays the operational cost. And then what amount of control do you have over where the transportation goes or the routing? Oops. So first is you buy a vehicle, which is very common. You buy a vehicle and you're responsible for basically everything. Usually you're not making the vehicle, but if you did, then you have to bear that cost as well. And quite frankly, when you develop an application, you are making the vehicle. What I'm trying to emphasize here, though, is that this whole operational thing applies whether you're building the software at your company or your company buys the software externally. No matter whether you made the vehicle or someone else made it, you're going to have the same operations kind of concept. If you hire a driver, you get rid of one of these things. So you basically outsource it. So if you hire a driver for a car you own, like you see on movies and stuff, someone has their own fleet of cars, but they don't want to drive them around. So they hire a driver, a limousine driver or a personal driver. If you rent a vehicle, you drop a whole bunch of these. So you no longer have to make the vehicle, even if you did previously. You don't have to pay the cost of acquiring it, nor of upgrading it. So if you need to go on personal drive this week, you take a compact car. You need to go on, take furniture, you go rent a truck the next time. So you rent different vehicles based on what you need at the time. The maintenance cost is not on you. The usage cost is, and the operations costs and logistics are on you. You have to drive the vehicle. If you take an Uber, then you get rid of one more thing. So we no longer operate or monitor it. We just sit in it. Taxi is another, Uber, I'm saying Uber, but a taxi would be the exact same thing. If you take the bus, now you start to even get rid of cost sharing. So now the cost is shared with others. So the cost goes down, but notice the control goes down too. So every other previous one, we get to specify the from and the to completely, door to door. But as soon as we take the bus, now we have to take common stops, but we're also sharing costs. And then finally, we have the last one, which is the train. And now we're sharing the costs even more. And we have usually even lower control over the routing or exactly how things work. So how does this equate to compute? So if we, the orange is showing the cost, complexity, maintenance, and skilled folks or full-time equivalents. So the orange is on us. And then whenever we have a green, that's behind what we call the service management curtain. So when you rent a vehicle, you're doing transportation as a service. You're taking up a service. And so the farther we go to the right, the more of the things are managed by someone else and not us. And the farther we go to the right, the more the costs are shared and we lose a little bit of control for that. So let's see how this goes to compute. Basically, this is the same as having your own data center. Physical computers, you have to upgrade them when time's to upgrade. You have to operate them. You have to provide the electricity. You have to provide the full-time staff. So this is the old data center model, is owning your own. Then hiring a driver is like co-location. This is also at this point a very old concept, but you used to be able to buy computers. You can still do it, but you'd buy computers and put them in someone else's data center. So they would operate and monitor it and pay those costs, and you would still have to do everything else. You just wouldn't have to own a physical facility. Then renting a vehicle is like platform as a service. So you may know that you can go on Amazon and you can say, give me a relational database service with 3 servers that is fault tolerant, even if one of the data centers goes out. Click, 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 and it says, hey, that'll be $2 an hour as long as you have it running. And boom, you have a very complicated piece of technology that you don't really have to know how to operate it or how to build it. All of that is done for you. Then Uber is like dedicated SaaS. So dedicated SaaS is when you go to a company and you say, hey, I want you to run software for me, but I want my own copy of it. I don't want to be in a shared copy of it, whether it's for data sovereignty, security, whatever. So when we do that, then we offload most of the things, except we still pay the usage costs, but someone else runs the rest of it. Then with a bus, we have shared SaaS. So this is like some sort of software application you use where everyone uses the same copy and your data is mixed in. It's usually secure, but it's in the same databases as everybody else. And this offsets some costs. And then finally, at the far end, we have scaled SaaS. So this is like Gmail, and you get it for free just because they're able to show you ads and other things. And so it's so scaled that it's free to you, but also you have basically zero control over what kind of features are available. You have to pick a scaled SaaS solution. So these green ones at the top are all aspects of the cloud, and they're all aspects of commoditizing compute, similar to how transportation is commoditized. You can obviously choose a blend of these solutions based on your circumstance. And so in a given organization doesn't have all scaled SaaS. Where I work at GitLab, we actually do. We almost everything that we don't build ourselves is we use another SaaS solution. So that's whether it's a dedicated tenancy, shared, or scaled. And so that's an example of some of the ways that compute is commoditized. Anyone have any questions or thoughts, reflections on this bit? For a lot more information on this idea, you can read a book by Simon Wardley called Wardley Mapping. So what is cloud? Cloud does scale, which we talked about before, through elastic scaling, the ability to get bigger and smaller based on at the moment demand. The cloud services speed by having software-defined infrastructure. We can have a data center defined as a bit of code and run it and stand up an entire data center. Also, those computing resources can automatically scale as far as the speed of the actual compute. And then safety, the cloud has reliability built in. So when you read about Amazon, they'll say, if you put your data in S3, it has 7 nines of durability, which means the chances of you losing one object in 1.5 million years, you might lose one object, one file in 1.5 million years. So reliability built in. So the cloud is really doing scale, speed, and safety as a service. All right, key takeaways. So some review. What I might actually do is just go through the prompted review that I had prepared. And then if we have a little bit of time after that, if you have things that, well, no, you know what, let's stick with this, because I'd like to find out as a form of feedback what you found was valuable about what kind of stuck for you and might make a difference to you as you go forward. So let's just review the key takeaways that you as individuals feel that this might have helped you with, and that'll be both a source of feedback for me as well as reinforce the concepts for everyone else. If you choose to do it audio, I'll probably type it into the chat and then save the chat so that I can retain that feedback. So what were some of the things that over the course of the entire time we've had together struck you as possibly informing, the way that you'll move forward in your career or with the projects you're working with right now? And if you don't want to voice, you can type them in chat too.
I mean, I really enjoy the way that you teach and make slides and you think about things, because you have such a broad knowledge that comes from so many different things, and you're able to really give us granular things. But I think what I'm thinking about a lot is when you're talking about when you were talking today about Agile, right? And how Agile came about for innovation, and how, when Agile first started, it makes that you can have up to 3 releases a day, but production and DevOps wasn't keeping up, or that doesn't necessarily work for that. And I've thought that, I guess, but I've never heard anyone articulate it the way you have. I don't know. I just felt like that was such a key takeaway for me to think about, because I think sometimes we think of agile versus waterfall, and waterfall is just like slow and hierarchical. But also I think what you're saying is it's like, what I understood is like, it's almost like it's larger than that almost, like, because we have to think of all the different parts that make an application run. And I don't know.
Good. Glad you found that valuable. Thank you, Rachel.
Yeah, I really appreciated that history and like your knowledge being able to do that.
And Alton says he enjoyed the breakdown between solution development and software development. That's actually a thesis I'm working much more deeply with another colleague that we are hoping to get out in the ether more, because we find that both of us are more on the solution engineering spectrum. And there are ways in which we have, when you go to make your case back to software engineers, you have these challenges and you're like, why are these challenges existing? And so I made a whole bunch of tables about how the two think of the world differently. For instance, if a software developer if someone says, here's the problem, can you solve it? Well, they're always thinking about, well, prove to me that 100 customers have the problem, because it won't be worth the money for me to build that and maintain it if we don't get more sales because of it or more adoption of the product. Where a solutions engineer, usually someone's coming to them and saying something like, look, we're ready to buy the product, but unless it can do X, Y, and Z, we won't be able to buy it. Well, a solutions engineer can jump in and solve X, Y, and Z, and the sale's already there, and the sale's worth a person spending time solving those problems. So the justification to build is completely different for these two roles. In one role, the justification for build is right there. We won't buy the $1 million deal unless you can fix this, or we'll pay you $200,000 in professional services to solve this. You have a justification to build. You don't care if any other customers need it or not. When you're building product, you're always resisting unless it's proven that more than one customer will need it, because there's a short and long-term cost to putting it in the product. And a solutions engineer can go, oh, there's 5 products that solve that. Let me pick one and knit it into my solution, where a developer is always writing the code right into their application. So there's some fundamental differences in the way they process the world. Other thoughts, observations, takeaways, key takeaways for you?
Yeah, I can share something. I think for me, one of the big things that I'm going to take away from this experience is when you talked about the 12 app, and forgive me the name.
12 factor. Yep.
The 12 factor, because that's kind of given me cause to pause to like sit back and rethink about how I would approach developing an application from the different steps that you've so eloquently kind of listed out for us, because you want to make something that's to just harken back on some of the points, that's not going to I guess break down or crash when you move it from this platform to the next platform, and little things like that like I hadn't really considered before. So yeah, that for sure, it just gives me a little bit more to think about as I'm working through like a project or an idea that I have, and trying to build it for with the operations side also in consideration.
Excellent. Thank you, Peter. Yeah, it's a really big concept. And I have been on DevOps teams where we're under the gun, and why can't you get this automated? Why don't we have more DevOps? And it was the same organization where the configuration for individual customers was embedded in the code. And it's like, because code has been developed pre-DevOps in a way that does not accord well to getting this done quickly. You have to refactor that out, and no organization wants to hear they need massive code refactoring to be more compatible with the new management methodology. So, any other thoughts, reflections, key takeaways? I'll go through a few. Also, Alex, I can go over and maybe we'll just go through some more key takeaways, because they'll be on the video. So for those who have to drop off, they could come back for them if they wanted to. Does that make sense?
Yeah, that works.
And then if you have more, just drop them in a chat or speak out. Also, Lorindo is saying that the difference between continuous delivery or deployment was a key takeaway. So what key concerns does DevOps make into a first principle of good application development? Very simple answer. Normally, when you're developing your app, you're not thinking about a massive part of its life cycle. What is that part called? Hint, it's part of the DevOps acronym. That would be operations or operationalization. If you remember the picture we had of the engine and the car. So your app development complete, operationalization complete. And so ops can only be ready to accept the rapid pace that you can build stuff if you take their concerns into full consideration when building, because otherwise it's going to be hard to run your software, and they're the ones proficient in what it takes to run scaled, secured software. And so you have to bring those concerns back in and be very open to the feedback about. And also I've found that as a solutions engineer, I can actually have a much better concept of what it requires to scale really strongly than the developers, because they don't have to scale. You're running it in a local machine usually, right? And so unless you actually participate in that part of the process, it's really good to be able to heal this divide. There's a set of development principles that take some of the hard thinking out of operationalization of applications for you. So you don't have to think as hard if you just follow them. Does anyone remember what they were and how many there was? Basically, if you follow these, you can do a lot less thinking about operationalization. That was the 12-factor app principles that Peter pointed out. So you can, if you develop towards those, you do a lot less thinking about all the operational considerations. And then we also pointed out how developing on Docker also kind of forces you to adhere to some of these without necessarily knowing it. You can also create anti-patterns. You can create a Docker container that's the equivalent of an entire machine. And sometimes there's actual positive reasons to do that, to make big Docker containers with entire app stacks in them as a first step. But if you follow the 12-factor app principles, you'll be much more set. What are some of the key operationalization concerns that worked into the whole picture of development? So we actually talked about, there's a couple slides with 2 blocks of 3 that basically emphasize some of the really big picture things that operations has to deal with that DevOps helps with. So we had scale. What were some of the other 2? Does anyone remember? Want to chat or call out the other 2?
Speed and safety.
Speed and safety.
Speed and safety were the other 2, right? So those are two major aspects. We had a figure 8 infinity diagram that we went through on the stages of DevOps. And at the very end, we put up a gray box around all of it and put 3 concerns in there that the whole process should be saturated with. Does anyone remember what those were?
I think operation, monitor, and plan.
So that's the ops side of the circle of the affinity diagram. But above, I had 3 things, and they were collaborate, communicate, and security. So absolutely everything has to be surrounded by those concerns. And if you can learn how to write applications that do not require administrator permissions that you usually have on your local machine, you'll be a lot better off for operationalization, because we don't want our apps to have administrator permissions in production, because if someone can hack into your code, they now have that level of permissions to do further hacking. So you really want to try to develop your code so it doesn't require that. And then why did the cloud emerge as a thing in computing? It has to do with a global human effect that affects many, many things that we build and work with outside of technology even. So we said it was a natural economic outcome of commoditizing compute. So commoditization means making it something that you can just go anywhere and buy and use easily. And what did we say was the key difference between solution engineering and software engineering? Basically, if, oh, was someone going to speak? Basically, if you like to make things from scratch, like pottery, painting, when you're creating things, then you'll probably be more enjoy software development or software engineering. And if you like to make assemblies out of made things that you kind of bolt and tape and glue together, then that's more like solution engineering. Okay, that's all the review questions I had. I've really enjoyed teaching you all about DevOps. I hope that it really helps you in your practical day-to-day career, as well as since you're all, like a lot of you are transitioning into this career, it may also help inform you as to how to be more effective in your chosen field, or look at other options within the whole DevOps spectrum of things that you can do. So thanks very much for your attention.
Thank you so much, Darwin.
Yeah, my pleasure.
Thank you, Darwin.
Thank
Yeah,
you so much, Darwin.
Don't be afraid to reach out on LinkedIn.